In January 2023, the James Webb Space Telescope identified a planet named LHS 475b, just 40 light-years away. It looked promising, Earth-sized, atmospheric, orbiting a red dwarf, but then we saw the surface temperature. Over 300 degrees Celsius. Hot enough to destroy any familiar life. No water. No chance. Right? Maybe not. What if life out there doesn't care about water, or DNA, or even carbon? What if our definition of life is the real problem? Here on Earth, life is carbon-based, and for good reason. Carbon forms long, flexible chains. It's the molecular Lego behind DNA, proteins, and everything that breathes. But carbon isn't alone. Its chemical cousin, silicon, also forms 4 bonds. In theory, it can build complex molecules. In practice, it already does, in microworlds we often overlook. Diatoms, microscopic algae found in oceans, encase themselves in silica shells, essentially living glass. They're proof that silicon-based biochemistry isn't just science fiction, it's already here, at the edge of what we call life. Now imagine life not as cells, but as intelligent crystals. NASA researchers have proposed that silicon organisms could grow like minerals, layer by layer, storing information in their structure. No DNA, no neurons, just geometry and memory. A broken shard might carry all the instructions to start over, just like a seed or a spore. But there's a catch. Minerals grow slowly. A silicon-based civilization might take millennia to achieve what we do in decades, but time is relative. And in a universe 13.8 billion years old, what's the rush? And then there's speed. Kelt 9b is one of the hottest exoplanets we've discovered, over 4,000 degrees Celsius, hotter than some stars. Here, carbon would disintegrate instantly, but silicon melts and flows. In these infernos, silicon life wouldn't slow down, it could accelerate. Liquid silicon organisms evolving at high temperatures, metabolizing metal vapors, thriving in a biochemical forge. Our assumptions of too hot or too cold are earthly limitations. The cosmos doesn't care. Now, let's flip the scale. Some exoplanets are colder than -220 degrees Celsius. Too frigid for water, but perfect for liquid methane. Methane can act as a solvent, just like water. On Saturn's moon Titan, we've found entire methane seas, complex organic molecules, and volcanic eruptions of ammonia and hydrocarbons. In 2015, researchers at Johns Hopkins proposed a new kind of cell, the azotosome, a membrane made of acrylonitrile, stable in methane. These cells could form gelatinous lifeforms in cryogenic lakes, slow, translucent, maybe even conscious. Floating orbs of alien biochemistry. They wouldn't just look strange, they'd breathe methane. And their exhale could instantly freeze an unprotected human. Life doesn't need surface warmth either. Some alien ecosystems might thrive beneath the crust, in oceans of magma powered not by starlight, but by geothermal energy. On planets like WASP-39b, the air is thick with hydrogen sulfide, toxic to us, but a potential fuel for chemosynthetic organisms. Imagine insectoid creatures with sulfuric blood and plated exoskeletons, burrowing through molten rock, spitting corrosive venom. They wouldn't see sunlight. Instead, they'd evolve radiation-sensitive eyes, tuned to heat and decay. Radiation to us is danger. To alien life, it might be food. Astronomers like Chris Impey suggest organisms that harvest energy from radioactive decay, thriving in places too lethal for Earth life. In these zones, evolution could produce X-ray sensitive vision, alien senses built for nuclear environments. What blinds us could guide them. And now, the unimaginable. Neutron stars 10 kilometers wide, denser than anything in the universe. Gravity so intense atoms collapse. Temperatures soar to 1,000,000 degrees. It's not chemistry anymore, it's nuclear physics. Some theorists propose that inside these stars, nuclear-based life could emerge. made of compressed neutrons and strange matter. No molecules, no cells, just quark patterns transmitting information, and they'd live fast. 1,000,000 generations could pass in a single human minute. Entire civilizations could rise and fall while we blink. But not all life needs to be organic. What if the most successful life form isn't born, but built? In 1949, John von Neumann imagined machines that could replicate themselves. Today, scientists believe such robotic life might already be spreading across the galaxy, mining asteroids, building copies, consuming planets. Maybe that ring of dust around Epsilon Eridani isn't dust at all. Maybe it's the skeletal framework of a Dyson sphere built by machines. Let's say we find a perfect exoplanet, lush, green, water-rich. We land, the air is breathable, the animals look familiar, even the fruit smells delicious. And then the crew dies. Not from poison, but from chirality. Molecules can be mirror images of each other, left-handed versus right-handed. If their biochemistry twists opposite to ours, our bodies can't process it. It's as if we ate a mirror version of our own food, identical in formula, lethal in effect. It's a chemical trap. We search for life by looking for ourselves. But the universe might be full of beings that don't breathe, don't breed, and don't burn the way we do. Some may be crystal, some methane gel, others nuclear shadows or self-replicating steel. We haven't found them yet, not because they aren't out there, but because we've never known how to look. Are we alone or just blind? Subscribe for more deep dives into the frontier of alien possibilities.